Okay, sir.
Okay.
Good morning. Good morning. Very good morning to all the participants. Welcome to the fourth day of the program. I think last 3 days you have been enjoying these lectures by the different experts members across the world. In the same series, today we have a professor from NIT Warangal, Dr. Venkata Reddy garu. He is associate professor in NIT Warangal Department of Civil Engineering. Now it is my privilege to introduce Dr. Venkata Reddy garu to the participants of this international webinar on climate change impact on water resources management and environment. To start with, let me introduce Dr. Venkata Reddy garu. So he is associate professor in Department of Civil Engineering, NIT Warangal. He has a postdoctoral work on climate change impact studies on river basins of USA using climate change model database, and he is a PhD degree from IIT Mumbai. Worked on distributed rainfall runoff modeling of watershed using FM, remote sensing, and GIS systems. Master's degree in hydraulics and water resources engineering, KREC NITK, Surathkal, and BTech civil engineering from Nagarjuna University. So he has a total 13 years of experience at NIT Warangal. Now he has handled so many projects, completed 2 projects and ongoing 4 projects. One of the project is development of rural information system using high resolution satellite data, GIS. It is a DST SERC sponsored project. Fast track project, development of precise real-time simulation of watershed modeling systems using advanced geospatial computing techniques, again by DST. And he has also developed integrated water management model for BIS countries under climate change scenarios coordinated by the BRICS. BRICS is a very good platform for the Brazil, Russia, I think China and Singapore. So 5 countries have been come together, South Africa, yes, to form a group. I was also a member. I was attending a program in Vizag in 2019. So it is a prestigious project done by Dr. Venkata Reddy garu. So now he has also developed real-time forecasting flood using SWAT models. The Spark program of the DST. So he has published more than 40 papers, 48 papers in conferences and in journal papers. He has also guided 4 PhD scholars, and ongoing are 5 PhD works are ongoing. And he has also completed 56 MTech scholars. So he has a thorough experience, and he has been working on hands-on work experience on climate change impact on water resources of the watersheds. With this introduction, now I request Dr. Venkata Reddy garu to continue with his lecture of the today's program. Thank you, sir. Over to you, sir.
Yeah, thank you, Reddy garu, for your nice introduction. And thank you for organizing this program. And really, this program is very much useful for the, you can say, different people who are working on this climate change and other aspects. So now with this, I am proceeding to the lecture. So climate change impact on water resources of the watersheds. So I think you are going to the different, you can say, experts, resource persons giving the lectures last 3 days. You may come to know some of the important aspects of the climate change, how it is going to impact the water resources. So now today I'm going to explain some of the cases where we are worked on how that climate change impact we can see on the water resources. So some of those aspects I will going to explain today. So I think most of you know by this time. So these lectures are previously maybe. So as you see, like climate means it is like a average weather pattern which is prevailing over a place over a period of time. So it may be like a decadal to centuries and beyond. So we are working on the spatial scale, normally extending from regional scale, like maybe from one river basin or one watershed to global, like maybe continents, countries. So climate change. So it's like a whenever we say climate change means normally we will, even though we will say local study, but when we are making an initial study, we'll do for a regional or you can say on a global scale. Then we will come to a local scale to address the issue. So climate change variability. So as we saw some of the things like it is extending for a long period, the variation, whatever the variability is there. So it is changing the, you can say, existing conditions, like maybe some monsoon shift may be there, maybe rise in temperature, maybe fall in temperature. Any of these things may prevail. So finally, the impact come to the impacts, we can see the impact on some of the areas like water resources. Majorly, we can see the impacts on water resources. So the hydrology, especially in the arid and semi-arid areas of the world, they are more prone to these climate variations. So there is a integrated analysis is required to understand first of all impacts of climate change. Then we need to study how to tackle this aspect. So when come to this impact study on the, you can say, impact on the water resources. So the scientific unit is normally the watershed. So watershed is the, you can say, one scientific unit. You can see the watershed. If you go for higher scales, it is like called a catchment basin. So as so many, you can say, combination of the watershed, it may become, you can say, catchment. Then so many catchment become a basin. So if you could able to understand the climate change on the watershed, you can easily extend for the, you can say, bigger like catchments and then river basins. So whenever we want to apply the climate change impact, we want to study, you need to use the, you can say, first initially the global circulation models are also called global climate models and regional climate models. And we need to take the data from these models and you need to apply with the hydrological models. So hydrological model is the one which is useful for us to understand how these inputs from climate models will really change the how the, you can say, various process which are as output from the hydrological models. So when come to remote sensing, it will provide the inputs which is required for the hydrological model. GIS provides a platform for simulations which we can do with the hydrological models. So whenever you say climate change impact study in the watersheds, you need the first one is the hydrological models. You want to select things and you require a climate model database, which is the, you can say, for it which will understand the present and future scenarios. So we can apply so many hydrological models. In the case studies which I am going to present, we use the QSWAT. It's one of the open source model that is called actually soil and water assessment tool. It is widely used for this climate change impact studies. We can give the different inputs extending from land use, soil, and we can weather conditions. We can run the model and we can visualize the outputs. So we can able to study the what is the present condition and future conditions. So if you take a typical case, how you can really apply this climate change impact model in a watershed. This is the flow chart. This is like you can apply for any number of, you can say, watersheds or any number of, you can say, any type of, you can say, basin, or even for the, you can say, other administrative units. Even it's not a watershed, you can apply, but the only thing is it become a multiple watersheds you have to see. So first of all, we have to select the watershed which you are going to study the impact. Then select the model, hydrological model, which you are going to study this impact. Then you need to get the climate model database, which is coming from different sources, which you can see. I will show the slides where really can get these data sets. So with all these inputs, so first of all, we need to prepare the databases, which may be the climate database, and the second one is the geospatial database. So when you go across the, you can say, slides, you come across the slides, I will show you how really this database will be there and what is the how they will look like, how you can prepare. I will explain you one by one how you can do for a given specific climate change work or climate change study. You can make this simulation of the water balance components of the watershed. So whenever we want to make this study, we need to basically we are studying the water balance. what is the present water balance or previous water balance and what going to be the future water balance. This it will self tell what is the change going to occur in future because of this climate change. So once you know the water balance, then we can come to know there is a impact, means whether it is going to reduce or increase or spatial or temporal variation will come to know. Then you can go for the next steps like a adaptation. Suppose some change is going to occur, it is like a compulsory or it going to be occur, then we need to make some adaptation strategies so that we can able to withstand those, we can say, changes. So any you can say climate change impact study, you need to have the following things. One is the climate model database, which is getting from the different regional climate models and global circulation models. Then we need to have the observed climate data that is coming from different sources like a Indian Meteorological Department and other sources. Like where basically we require like something very important thing like a rainfall and temperature when we are studying about the water resources. And we require to stream flow, like some observation records are required to understand what is the changes. Since we know what is the things which are existing, then we come to know what is the change which is going to occur. So different physiographical database, which is I can say where the hydrological models work, we need to prepare this database whenever you want to initiate this hydrological models. So first one is land use land cover, which is the most influential input, and soils. So most of you know that the soils is the make a lot of difference when you are working with the hydrological models. So all the flow, how much flow is there, how much is going to infiltration, how much is going to gauge floods, most of these things will depend upon the soil information. Similarly, one more information which is going to influence is the digital elevation model. So this digital elevation model really so give the, you can say, what is the, you can say, influence on the surface, or you can say surface flow. So the topography, that is the, you can say, basic, you can say, information or topographical information, it is influence a lot the water resource system, like how the rainy river basin flow, when it rainfall comes, how much really cause the flood. These all things will we can explain or we can prepare or we can simulate by using the digital elevation model. So when we come to the climate model database, whether you see the global circulation models or regional climate models, so where these data sets are available, how to get for a given, if you want to study suppose some area like a suppose any of the like a part in Andhra Pradesh, part in Telangana, or part in other Krishna basin, Godavari basin, we need to have the first of all these data sets. So general circulation models are global models, so they have the complete information about the whole, you can say, globe, how the climate is varying for the maybe last 100 years, and they will give for the what going to be happen in the next 100 years. So there are so many tools are there which you can able to use these tools, and you try to get for required area. Means normally these data sets are available for whole globe. So when you study for Godavari, means you have to use for that data only. So we need to have some use to some tools so that we can able to clip or you're able to cut the data to the required field or required number of years. Accordingly, you can study. So normally when you take the global circulation models, they are the, you can say, one grid if you take, it is in the range of 100 to 500 kilometers. Means it's like 100 by 100 or 500 kilometer by 500 kilometer. So very coarse. So like most of the city or most of the areas like we cover in one grid only. So normally we need some variation in the temperature, variation in the climate. So it will change from place to place. So that we need to bring for a smaller variation also. We need to go for the regional climate models. So normally this we can achieve by downscaling. Yourself can do the downscaling thing for a finer resolution, or you can directly download this even this regional climate data. So they are like a order of like a maybe some 10 kilometer by 10 kilometer, 20 kilometer, 20 kilometer, or you can see it's like a 0.5 degree by 0.5 degree. So or 0.5 degree means it's like a very small, like even you can say we can get so many points of a particular area. That is important for us to understand this climate and then to apply later for the hydrological model. So suppose we have the global circulation data is there with you, you want to downscale it to the required region. Suppose you have to have the whole world data is there with you and you are download for the Godavari, where you want to further downscale to the, you can say, small you can say points, which is the order of like a 10 square kilometer by 10 square kilometer. So we need to go for any of the downscaling methods. One may be the statistical downscaling, other is the dynamic downscaling. So in the statistical downscaling with the available data from GCMs, you try to take the some observed parameters. So with that observed parameters, you will find out the statistical, you can say, information. With that, you will try to downscale to the, you can say, required cell size. So that is the one of the things. So many softwares are there, or ourselves can do that one, is statistical downscaling. So we need to bring the relationship between some observed records and these climate models. So for downscaling purpose. And come to dynamic downscaling. So normally these are the, you can see, models. We need to run some models like a WRF, that is called weather resource forecast model, or there are something called PRECIS model is there. So there you give the global climate data and you try to give the, you can say, model itself that what is the scale you want to, you can say, reduce your data. So it will simulate the data for as per your requirement, like a 20 meter by 20 kilometer by 20 kilometer like that, and it will give you the, you can see, information. So you can get the feature data, you can get the whatever the way you want, and most of the times this all works both the things. Sometimes it may be difficult for you to do. So what we can do is most of the climate change works we can download from the, you can say, websites. So many, you can say, authorized, you can say, government agencies, scientific centers, they are working on this downscaling aspects and they are providing the data to the scientific users or scientific, we can say researchers they are providing. So we can use the data directly so that this work will reduce. So if you are really interested to want to make a more work, means definitely you can use this data. Means you can take the global data and then you can downscale yourself. Otherwise, you can already directly available regional climate data you can download and you can use. So just for example, this is the one of the site where you can get the global climate model data. So you can just like any of the research if you are doing in climate change, you can go to this type of sites and there you can download the data sets. Normally these data sets are, you can get these data sets for the whole globe. But suppose you want to for a particular area, so you can you need to, you can say, clip. So there are some tools are available in the R programming language, Python language, or any websites are available. You can clip to your, you can say, required area so that you can use for the area. So otherwise you can't able to handle this data. It is like available for some 100 years. Every day data will be there. So it become a huge data set. This is some of the, you can say, options available for you to download the data sets. So there are so many models are available. Climate models are available from different centers. You can download. Normally the, you can say, any climate change study you want to apply, minimum you have to take the 5 climate models data you have to take, and you have to do the work, and then you need to take some average of these all the things, and then you can present yes, whatever the result you are going to present, a future like a change you are presenting or you are saying impact, we can say confidently, okay, this is going to be changed this much. With some, you can say, level of, you can say, probability, you can tell what going to be happen in the future. So some of the, you can say, just like available, you can say, data sets where you can make. So normally one thing we have to know, this data set is available in .nc format. This is called actually netcdf format. All climate data sets are normally available in this format. You need to download this format and then you need to have some programming, you can say, things or tools to convert this NC files to regular, you can say, your you can say, models format so that you can able to apply the data set. So suppose I said now, like if you want to use the regional data, this is called, one of the website is called Cortex. This is called coordinated regional downscaling experiment. So instead of applying the, you can say, global model, what they did is they divide the whole world into different regions, and each region they are applying the climate models. So then they are getting this regional climate data. This is like a more useful for you to whenever you are doing for a local level, you can say, basins you are applying, or you want to study the, you can say, small areas, you can use this regional climate model data sets. So this is like a very you can say part. Now we can see like our India comes under Southeast Asia part. There you can go to that website part. There you can download the thing required for our Indian subcontinent. So which you can use for the studies. So this is the, you can say, portal for our South Asia. Like this is like maintaining by Indian Institute of Tropical Meteorology. So Center for Climate Change Research. So this data you can download and you can use for your, you can say, studies. So if you go to the, you can see this website, they will give you a lot of, you can say, experiments they conducted, they run the models. So you go for a number of years you require, type of model you require, and how much data you require, everything you can ask. Accordingly, you can download. So you can download and you can use this data set. This is the, you can say, type of data set we can get from this portal. This is, you can say, it is available in the, you can say, folder. You can download to the required, you can say, download to your, you can say, place from this, you can say, FTP server. So all the models data is available. Like there are almost like 21 models data is available. You can decide, you can use few models you want to use the, you can say, you can work some more advanced study, like you can take the ensemble average approach, or you can go for the regional, you can say, average you can take, and accordingly you can select the which models are influential for the study area. Accordingly you can use those models. So most of the times once you download the data, we need to visualize this climate data. Otherwise, you may not know whether it is particularly falling in which area, and suppose whether it's coming to your study area or not. So this panoply, just you can down. This is for visualization only. You can't do any, you can say, clipping those things. For that purpose, you have to use the R programming or Python programming tools you have to use. So this is just to see the data how it is there. So just like this is one of the example where we just like opened one of the small data set which is there for the southern, you can say, American, you can say, continent. So you can see this is the data for like precipitation. So it is given the, you can say, whenever you download for this netcdf file, its extension is a .nc file. So this is the format you can see. So this is the data, like the same thing we can do for India and any other part. So it's like one region. So suppose if you do for India means it will come for the Indian Southeast Asia whole zone it will cover. This is the way how you can see the data set. So like you see, like each and every grid point, what is the rainfall which is there, what is the, you can say, temperature, what are the information which you can able to see. So like this huge data set is there. This is like a certain, like 100 years. Every day you see huge number of data set, you can say, size. So there any particular data you want to see, you can easily see by using this visualization software. This is like a starting step for you to work with the climate model data sets. Okay, so yes, as I said, like a first step in the whole this impact studies, climate impact study and water resource of the watersheds. First step we could able to prepare the climate data, like a regional climate data, and you can say you could able to prepare the data required for your study area. So then you are, you can say, going to, you can say, have the, you can say, observed climate data. So you have the, you can say, climate model data for the present and you can say the future. Now this observed climate data is the available from the sources like Indian Meteorological Department. So nowadays, previously we need to procure from this Indian Meteorological Department. Now they are providing, if you go to their website, they give a complete data set, almost like a 100 years, almost like a 70 years data. It is available for you to use, and you can apply the, you can say, most of the areas they given as a gridded data for a rainfall 0.25 degree by 0.25 degree, temperature is 1 degree by 1 degree. So like this data is really very much useful for the most of the climate change studies for across the India. So any part of the India you can able to work with these data sets. So this observed data is required for you to know, we can say, when you are applying for the present condition and to study future condition, we need to know this observed climate data. This the, you can say, site where you can go and you can download the required data for you. You see the, you can see the how it is available on data sets. Okay, so then you can see the some of the, you can say, observed, you can say, data sets which are available, like not only observed temperature and rainfall, we need to also have the observed gauge. So whenever I say watershed, basin, river, so there we need to know the observed flows. That flows, so that is like available in form of the stream gauge data, rain gauge data may be there, like even rain gauge, observed rain gauge stations. It's not like a gridded data, it's like observed station data, reservoir flows. You can say even the groundwater observations. Okay, most of the data are input data required for you to set your hydrological model for a given climate change impact study. Okay, so Central Water Commission, which is like a organization which is like a collecting data over the years and keeping a repository. So any study we want, really we can approach these people for, especially for most of the river basins at a different gauging point. They have data most of the years on daily basis, you can say. So they will provide for you, you can say, for any of your research works. Most of the times they are like a free of cost they will provide. Even State Department, they are collecting data. So you have also like a nowadays like a very important website or also called as a repository. So you called ISRO India Varies. So this India Water Resource Information System. So this database, you can have a complete, you can say, information about the basins, watersheds, and their input databases, and most data sets. So you can download from the source itself. So this will make your climate change study very easy. So all the initial data sets, not to do by yourself, you can download from this India website, most of the initial inputs. Then you can straight away start with your climate change impact study. So this is the website of the India Varies. You really can get the benefit of, we can say, these data sets, and most of the things are, you can say, live sometimes. Most of the repository data sets are there. So you can have a lot of, you can say, applications with these things, and then you can really get the benefit of using this website data sets. So that instead of preparing from scratch by yourself, you can get most of data from this website, all the initial data sets. Okay, so when you are have the, you can say, you have the hydrological data with you, like a rainfall, temperature is with you, and climate model data is with you, then you need to prepare the, you can say, physiographic data of the watersheds. In one of the, you can say, important thing in the thing is like a land is land cover. So land cover means what is there on the surface of any of the place, like a forest, lakes, what are the existing things. And land use means what exactly the human beings use the particular land. What is the economic function of the particular land? So we can say residential use, urban use, like that. So these are the important inputs for any of the hydrological models. So you see, depending upon the type of the surface and what is activity is going, accordingly, you can see the hydrological process, maybe like a runoff for the surface, so floods, and then how the infiltration going takes place. Most of these things are influential by the what is the land is land cover there on the surface. So you can prepare this data set by yourself by using the different remote sensing techniques, like a superimposer, you can say, interpretation you can do, or you can go for a supervised technique, unsupervised, and knowledge-based classification. Most things you can do by yourself. You have the satellite data with you, or otherwise nowadays most of the data sets are already prepared for most of the river basins or watersheds across the world. So for you, just you can see which is suitable or convenient for you. Accordingly, you can use the data set. So you can see some of these, you can see data sets which are really available for you. So like here we have the, you can say, global data sets, they are called actually. So they are all available for most of the, you can say, world. So you can take your basin boundary and you can clip it by using your remote sensing JS methods, and you can use for your study. So you can prepare by yourself, or you can use this type of, you can say, websites, and you can download for your study area. So that is the, you can thing. Or otherwise, even hydrological models we provide also, but model itself will clip the data for your work. So here, this is the, you can say, one of the website where you can get the land cover data. So USGS. So they are providing for the whole world, or you can say complete thing. So you try for any area, you can get. And most times they are like a repository, like they will give for a even spatial temporal scale, means like even previous data also, archives also we can get. And when come to India also, we also have a very, you can say, good repositories of these data sets. So they are really very much useful for your studies, especially we are studying on the water resources aspect. You can really bank upon these, you can say, what you can say, databases, so that your most of the initial work will reduce, so that you can focus directly on the climate change impact, you can say, studies. So far as for Indian data sets, we have the portal. I think most of you maybe saw this portal any point of time who are working on this remote sensing, that is Bhuvan portal. So here they are providing most of the data sets, most of the remote sensing data sets for any type of the water resource related work or any other related work also we can do with this website. So they will provide the existing data, previous data, and they will prepare so many thematic layers, and they are provided to the users. Most of things they are like a free of cost. The simple login password creation, you can get most of these data sets. So this is the, you can say, thing you can see. So where you can have the, you can say, database, you can say, thing here. So here you can see some of the, you can say, things here. You see land cover, like even it is available at 1:50,000 scale, you can get this data set. Okay, different data sets you can get. So even the, you can see what, you can see some of the boundaries available, and then what is the year, all this information you can get. So they're all like useful for you to do your, you can say, particular, you can say, research work. Okay, soil data. So most of the times when you're preparing soil data for your work, so you need to, you can say, they are the, you can say, grouping of the, you can say, different, you can say, the properties of the, you can say, which are there in a particular area. So you can group them as a different categories depending upon their, you can say, properties. So like maybe texture, color, moisture, void ratio, so many properties are there. Accordingly, you can classify the soils of a particular area. So they have a huge influence on the water resources aspect, or you can say how the hydrological process occur in the watersheds. So you can go for any of these data sets, or you can prepare yourselves. Most of the times, there is like a USDA classification is available. Most of the overall all over the world they will use these data sets. And National Bureau of Soil Survey and Land Use Planning, which is our Indian database, is also available. You can decide like which data sets is useful for your research work. So you can do the, you can see these things by field observation, interpretation, case, remote sensor data, or so the best thing, suppose if you could not do, or you want to work almost like these are the data sets available for the, you can say, things. Most of the researchers, they are like a work on these things. They will use the database. For example, like a first data set, that is data set provided by the FAO. That is like a United States organization, you can say, part. So they are all providing all these, you can say, things. Food and Agriculture Organization of the US United Nations. So they are providing complete data set of the soils. So you can download for a particular area, and then you can use for your, you can say, studies. So these are some of the, you can say, information sources where you can download these, you can see, data sets you can use for your work. This is like our own, you can say, these things. We can, most times we can say they are not directly keeping data, but still some of the most of the things are available. You can contact them, they will provide for a required area if you really want. The next one is the, you can say, digital elevation model. So the digital elevation model is the, you can say, 3D representation of an area. So this is like a, most times hydrological model use this one to represent like how the flow takes place in the watershed, where there is any flooding will be there, or any there is like a erosion is taking place. All the things will be decided by this, you can say, digital elevation model. So it is like a available in terms of the, you can say, one roster. So maybe most of you like who are working on remote sensing, just they know what is in the roster. So it's like a area of, you can say, cells. So each cell, it contains the what is the elevation of a particular area. So this data set like directly we can use in most of the hydrological models to use your, you can see, get your work. This is like a typical demo of an area, how it look like, and where you can use, you can see this, you can say how you can study this one. So this is like a, suppose this whatever the, you can say, dam, you make it as a, you can say, 3D visualization. You can see this one. So you see this is like a typically representing the realistic view of how the water, you can say, flow takes place in a natural terrain or real terrain. So you can see where the water stagnates, where the water flows, how much area is available for, you can say, water to store, which are the drainages is carrying the water. Most of these things you can understand by using these digital elevation models. So most of the hydrological studies you want to study, this is like a basic input you require. So most of the times these data sets nowadays available as a, you can say, most of the, you can say, dam missions they are called actually. So they will prepare all over the world, these data sets they will prepare. So one is like a space shuttle radar topography mission, Aster mission, and JAXA global mission. There are the different sources. You can go any of these. You can use any of these things for a particular your study. So only thing is you need to look at the, I can say, given data set. What is the cell size? What is the resolution? What is the accuracy levels? So you can use, if you want, you can go for multiple dams also for a given studies to know which one behaving better. So our Indian conditions are considered when India. We also one they are preparing one is called Kato Dam, which is prepared from Cartosat satellites. This is also you can use. So most of these are available for almost like a 5-meter resolution for most part of the, you can say, India. So this is some of the physical terrain. So you can see when it is applied, So this is the way that dam will come. You see this elevation, the same area, like this is some of the things we studied. The physical area, and this is how when you prepare a dam, how it look like. So this is a dam, and if we say slope, both of these things are, you can say, useful for you. So these are all useful for you to understand that, you can say, later for you to, you can say, most of your hydrological model, like at what velocity water will flow, where the water will stand, and where the erosion takes place. So all the things we can able to quantify. So this is the land use land cover, typical land use land cover, you can say, of an area. So you see, when preparing the map from satellite, this is the way it is available, like agricultural land, forest land, wasteland. So this is the input which is going to the model, any of the hydrological models. So now I explained you, I think you can follow the, you can say, thing, how to prepare a climate model, you can say, database set from different sources, how you can download, like a regional data, climate model data, and regional climate data and global climate data sets. You also, you can say, understand like how we can prepare the different physiographic data, like a land use land cover, soils, dam, and how to, where to get this all the observed climate data variables. So these all make your basic inputs, starting inputs. So if you are able to make all these things ready for a given study area, then yes, you can go with your next step, like how we can study the impact from the different, you can say, climate change scenarios on a particular area. So just like already first step I explained you, so how we can prepare the climate model database for the present and future scenarios. Present means like a last 100 years, you can say. Future means you can take as a next 100 years. Scenario means like a different scenarios are available. Like suppose in future everything goes as usual, everything like a worst condition, or you can say best condition. Like that, the scenarios are available. So with that scenarios, we can have the climate models which are already simulated, the storing database. Those things we can use. And we can prepare the things. That is the first step. And the next one is the input climate model database that already told to you how to make those things. So once we have the input climate and then we have the climate model database, we need to do the bias correction. Means most of the times models are simulating, so they have their own, we can say, domain. So they don't know what is the physically some of the parameters which are influential, how the data is changed. So we need to correct the what are the climate model which is available data to the observed data, so that we can have the bias. Then the data is ready for the applying for the watersheds. So means it's like some type of, you can say, correction for the, you can say, data which is you have from obtained from different climate models. So once the second, fourth step is the preparation of the geophysical information or topographical information of the area. So this already told to land use land cover, soils, all the things. Now once these are already up to fourth step, things are ready, then you are doing really the fifth step, where the input to all these data sets, and you try to understand the present conditions, whether a hydrological model which is selected is working or not, or you can make it like ready to, you can say, apply for the future conditions. So what you will do in this step is you can apply the, you can say, observed data, you can say similar data, you will compare, and you try to improve the parameters of the model in the calibration step. Then you see you will have some parameters like a coefficients will be there, like a Nash cliff efficiency, error coefficient, regression coefficient. So they're all like help you to find out whether you are doing the calibration, improving the parameters, helping or not. Once that is done, you are going for a validation. A new data set you will take, and you will check whether your model is working fine or not for the given conditions. So once this is done, fifth step, yes, you can say now you are ready to apply your historic data and future climate database for a given watershed. Historic means from the climate model which is corrected, bias corrected data. So what is the present conditions, what is the data? And future means like next 100 years, like maybe 2020 we are there, maybe you are simulating up to 2000 or 2100. So that is the data, you can say, we are going to study the type of things. And once this step is over, once you will get the models from the model, what is the stream flows, rainfall, temperatures, how it's going to change, then you are going to analyze. Like you will find out like, okay, this particular basin 10% is reducing, 20% is changing. So only one area, one part of the basin is changing. So like that, or only some next 20 years only changing, later the things are fine. Like that, you are doing different analysis steps. Then really you are making the, you can say, some adaptation techniques. So in my explanation, I will tell you the up to seventh step, how you can really from the fourth now onwards, fourth to fifth step, how really you are working on the different, you can say, aspects of these ones, like how you are doing the calibration, and then how you are preparing the model historic and feature application, and how you are going to analyze. So now we can see the case studies, like it's like a step-by-step application to the, you can say, different watersheds. So in this, I took the two case studies. One as where I worked as a postdoc research, one of the watershed. There, that work is conducted by my MTech student, and then further worked. And one more, you can say, study by our postgraduate students on the, you can say, or Indian, you can say, watersheds. So these case studies one by one, I will try to explain you so that you can get what are the steps I am told previously, how we can make each one, and then how we can see these data sets. So here, how we can study the impact on a watershed, given watershed, using the QSWAT model. QSWAT model is the one of the, you can say, the hydrological model, which is widely used by the, you can say, most of the hydrologists for this analyzing the, you can say, hydrologic regimes for the present and future scenarios, and it will also help us to, you can say, understand the, you can say, various, you can say, process stream flows for the future conditions. So the main goal in this particular study is to find out the anomalies any are there and trends in the hydrologic regime future. What is the going to be trend, whether it is like a reducing, increasing, or what is the case we will study in this. So the results I will present, and most of these things, what are the case studies I am presenting, both are got published. So at the end I gave the publications also. Some of you are interested, you can refer to those things. You may get a more detailed things. It may be, you can say, useful for you. Suppose some of you are doing any research on these aspects. So here, as these are all like steps which are already explained to you previously. The tips now they are all available in a form of the, you can say, flow chart. Like here, we are having the geospatial data which is available. You can say data set. So like just now I told like a dam, LULC, soil map preparing, and climate data sets which are available from models and observed climate data. So here we are doing the bias correction of the data sets, and then we are using for this thing. So first of all, we are setting a QSWAT model, and we are providing all these data sets as a inputs. So these input data sets, the model, we can say, use these data sets, and it will run the model. So first, as said, now like to you, we can have to make the some calibration to you. Calibration we have to apply first. Then we need to apply validation. So in that, we will try to improve some of the parameters so that you will try to come up with a data set which is really exactly, you can say, happened whatever is there in the basin. Then we can apply for the future conditions. So then the last step is like impact analysis. So here, this is like a one watershed, this is like one of the postdoc research when I'm working. So this watershed is called West Nishnabushnau watershed in the USA. So this is like one of the river basin where there are so many just like a rolling uplands, wide valleys are there, and it's most of the things is like agricultural area. It is 80%. Some glacial deposits are there, but most of the things are like agricultural land here. This is the, you can say, Iowa State. This is like located this river. So most of the data sets I said to you previously, we have to geospatial data. This is like Aster data set we used on land cover map, which is downloaded from the available website from the USA, that particular area. And soil map they are completely providing on the, you can say, this their complete websites are available where you can get a detailed, you can say, soil maps. Similarly, the precipitation data sets, maximum minimum temperature, like observed data sets, we can get. These are the some of the government websites in USA where you can get these data sets. So here, so this is the stream flow available for the particular the study area. So here, this is like taken from the, you can say, 20, you can say 30-year data set is taken from the gauge station. So here, this climate model data is available from the this is like I said like so many global websites. Similarly, for the regional climate data for the American, you can say, continent or American country, so they are providing a separate website where you can download the data sets. They are providing historic data for some 30 years, and similarly future like 2041 2069 like 30 years. So that is like the two different sets they are providing, and they are working on a different models, almost like you see like 5 climate models. they are providing, means more they are providing. We took the I can say 5 models and we downloaded the data sets and then we used in the study. So this is the I can say data set where you can see the right now the I can say things here. These are the you can say different you can say weather stations which are available in the area, and this you can say round circles ones are the climate grid points. You see the grid points, the climate models. So we need to see the what are the observation points and then where it is there. So that particular points we need to do the bias correction. We need to apply the you can say bias correction formula so that the data set which are available for the feature and historic data which is available from climate models we can apply to the hydrological model. You see the you can say some of the you can say now like a this is like a one model. So now I am showing like a different climate models. Almost you see 4 different climate models are there with different things, and we have the you can say watershed boundary which is there. So like how these all points are falling. So these points normally sometimes they will fall in a same place. The grids are different means they may fall in a even different place also. So but whatever the things, so they may these data sets you have to bring into the environment where you are working in the hydrological model and you to give as a input. So then here we need to set up the model. So now we have the data sets are ready with you, like you have downloaded some data sets. So now we need to set up the model in the QSWAT you can say environment that is called QSWAT model. So that like a where we have to provide all these inputs. First of all, like a we have to add the you can say location of the you can say study area. You have to give the basin boundary. Then the model is dividing into the whole area into different subbasins, small units. And if you provide the land cover map for the whole world, it will consider the watersheds which are available for the given study area. So this particular watershed contain the croplands, basically the major things, and remaining few things are the some water bodies and some residential, medium residential lands. And most of the things are like simply the here we can say soil class the loamy soils, most of this area, which the studied area. And then based on these things like a land cover, the model divide the whole area into HRUs. HRU means it is called hydrological response units. So like they based on the land cover type, soil type, slope type, dividing into the each one into a one separate category, which is called a hydrological response units. So it's like a fundamental units in this model. This hydrological response you combine that become basin. A basin you combine become watershed. Then it become a catchment. It become a bigger you can say unit. This is the you can say different subbasins of the you can say watershed. You see almost like a 17 subbasins are there. This watershed. The you can say one here. You can see this is the outlet. So from each basin it will simulate the water and it is finally bringing to the outlet here. So there you are going to you can say get the stream flows and how they are there and how much is coming, how much is reducing in future, all the things you can able to study. So once you are doing the you can say your you can say data input is ready, your database geospatial data thing everything is ready. So now you can go for the you can say SWAT cup, one of the you can say calibration validation tool available in the QSWAT model. So there this tool, so you have to provide the observed stream flow data, like whatever the period you are going to study. So this is called actually the 3 periods they normally call. One is called warm-up period. So 3 years warm-up period, calibration period 8 years, and validation period. So whatever the data with you, you divide into 3 parts. So warm-up period means there you can't take the data for any purpose since that is just only for model to get you can say warm-up means like it start simulating the data and correcting the results and then go on making a number of iterations. So the 5th year onwards, the data is available for you to change the parameters, doing the calibration thing, so observing the records, all the things. Validation means like next you can say 8 years, where you will just simply will not change any parameters, but simply will simulate and you see whether really they are coming in a proper way or not. The simulations will compare with the observed data. The comparison parameters here are the Nash-Sutcliffe efficiency and coefficient of determination. So here Then once you are before going to the, you can say, any of your calibration or validation, we need to make the, you can say, sensitivity analysis. Sensitivity analysis means there are so many model parameters in the model. So each parameter is influential the hydrological process. Some may influence more, some may influence less. We need to find out which is influencing more, which is influencing less. Accordingly, you try to change the values when you are doing the calibration. Otherwise, you do not know information about this thing. So some parameters may be very influential. You may miss those parameters. This particular case, you see the, you can say, here AWC and something called, you can say, curve number here. They are like a influential parameters at the HRU level and management level and soil level. So these values is small, the T-stat and p-value, they are big. So this information will help us to take which parameters in a model calibration. So no need to work with some 100 parameters are there, some 20 parameters are there to work with all those parameters. You take the 5 or 4 parameters which are really influence, you then change those parameters and you can work so that you can complete your calibration process. So this is the some of the, you can say, calibrated, you can say, parameters and fitted values and how you change it. So here is already the some of the scholars may be working in this model. They may know what exactly the meaning of these parameters. So there are the different parameters. So they will influence or they will change. So how this really the, you can say, get the, you can say, this parameters. What is the final value after doing this calibration? It is giving a correct, you can say, model simulation. This is called fitted parameter. So with this, all these parameters, if you're able to simulate the watershed, you may get some observed records, some simulated records, which are comparable, like maybe some 80%, 90%. So with the observed data sets, with that we can say, okay, our model is, we can say we are able to fit it for a given basin. So the some of the, you can say, parameters which are using the, you can say, calibration and validation. So here, so we have the calibration and validation, you can say, parameters which are there. So where the, these are the things we need to check, like R square, what is the value, and similarly the Nash Cliff efficiency, what is the value which is occurring. So these are the parameters. You see, there are most of the things are available. You can say you got the values more than, you can say, almost like 80% in the calibration R square, and then almost 60% in the NSC, and validation also they are coming in a similar range. So we can say yes, our model is, you can say, doing good in the calibration validation steps. We can go for the next steps. Okay, so before going to the results, this is like a, now you set the, you can say, your calibration is done, validation is done, you set the model, everything. Now your, you can say, results start for the this calibration and validation period. Okay, so we just like a, now next okay, so onwards I will explain like a various results which are getting in calibration validation period. Then for the future climate and past climate, how these data sets are varying, all things I will show you one by one. Just like 1 minute gap will take, and then we will show you the things one by one to you. Yeah, coming back to the next, you can say, explanation, like results and discussions, where you are applying this, you can say, models, and where you are, you can say, trying this, you can say, applications. So first of all, you see the mean monthly temperature for the historic period. You see here in the, you see here, these are like a different climate models, and this one is the observed one. So here, observed data means which is getting from gauge stations or IMD data sets. Other things means climate models. So what is the data which is given by climate model, and what is the data which you are getting by the different, you can say, observed data set and climate, different climate models. You see the different, you can see here in this case almost like 5 climate models are there, and you the observed one. So you see the trend or pattern is same. Maybe one is like a more like especially the observed case, most of the things you can say they are more, but remaining all models they are sometimes like a behaving one above and one below, but most of that they are following the trend. This is like a 12 months. What is the mean monthly temperature over a time period? This is like only for the historic period, and they are behaving you can say closely with the observed data. That's what is the thing we need to understand here. So similarly, the minimum temperature for the historic, previously maximum temperature is the minimum temperature. So what is the observed one? How the models are there? So the minimum temperature and how the historic thing. You see, they are all bunching. The meaning here is it is a bias corrected. So they are like behaving almost like similar to the observed data set. There's some little variations here. Then when come to the precipitation, like over 12 months, each month is like a 30 years like a average. If you take each month January, what is the observed record which is there, and what is the record which is getting from different climate models. You see the trend, most of the things they are following trend except in one or two models. So they are following like things. So only one observation you need to make here is the climate models, whatever the rainfall which you are going to get is more in the historic period. We could correct this by bias correction. Still, it is still some bias. That's what is the thing we need to know here. So here, so the you can say once you got this, you can say results. So here, right now, whatever I showed is the you can say data sets which you are getting from the climate models. We need to make some bias correction. Normally, R programming things. So I think some of you maybe who are working on this, maybe some research you are doing or your faculty are there. They will be working on R programming things. There we have so many methods are there, techniques, functions, tools are there. You can apply those tools and you can do this bias correction. So this bias corrections we can apply for the you can say different models. So the collections which you are applying for the historic data, we can compare the historic data with the observed data, and we can correct each and every value. Suppose on daily basis we can correct. Suppose you are getting some you can say 20 mm in the you can say climate model, maybe some 18 mm in the observed data. So the 2 mm is the you can say bias that we can take over the months. You can average it. That bias we can go and apply for each and every data set. Suppose after bias you are doing correction, it may be coming some value like some 1 mm. 1 mm you are applying for all days of the climate model data set, so that you are going to get with the your corrected data set. Okay, so here you see I show the you can say the formulas which you are going to use for the these corrections, for the bias corrections. First you see the some of the statistics we will use for this bias, that is like a mean monthly parameters. So some 30 years. So each January month, like it is called mean monthly parameters. What going to be the temperature? What going to be the rainfall? What going to be the precipitation? Maximum minimum temperatures. These all things will make it average. So you can try to take this monthly annual parameter variations. You can try to make it, and you try to apply these things to the data set. So first of all, you apply this correction for the historic data. Then same correction we can carry forward to the future data set. So here you see the corrections to the climate data which are available for the you can say bias corrections which are available. These are the basic formulas. Here rainfall forecast for the historic data you want to have. So this for the this is for the corrected one. So we need to rainfall historic you can take. We can multiply the mean monthly rainfall of the observed by mean monthly by rainfall of the historic. This is called a multiplicative factor, so that you can get the historic data you can say correction factor. When come to temperature, you take the observed and historic difference. That factor value you add it to the each observed or each climate model data set, historic data set, so that you can get the corrected one. C means here corrected one. Okay. So what are the correction factors which you are getting here? Simply we can say these correction factors, additive factor for rainfall, multiplicative factor for the rainfall, and additive factor for the you can say temperature. You can apply for the future data also, so that you can get the future rainfall and future temperature. So these are similarly the you can say you can apply this you can say corrections like a delta corrections they are called. So these are the, you can say, instead of using the previously we use the historic data. So in the future you want to simulate means they only took the, you can say, future rainfall data. With that they applied the, you can say, historic compared factors that they applied. So this is like any method technique we can follow. Normally the previous method will follow, and there are so many advanced techniques are there to correct the biases between the observed data and climate model data. So these are some of the, you can say, biases between the things like a rainfall, minimum temperature for each month. How much is the bias? This is like a bias amount. So from the base you take what is the January month bias for the, you can say, minimum maximum temperature, maybe the rainfall, what is the value, and what is temperature. These are the things. So you see the more bias means there from the, you can say, baseline means there is a lot of, you can say, variation between the climate model observed and this one. It's like a one model. Similar, you see the so many models are there. That models also we can able to check it actually. So each model you can take and you check the bias. Later, so you can use the ensemble average of the bias and to correct, or you do the some advanced techniques are there. You combine all the things, that is called ensemble averages. So with that thing you can able to use the, you can say, project the future data and then you can use. Okay. So some of the, you can say, once this is the final, you can say, results. Yes, you bias corrected the thing. So the calibration validation is done. Now you are applying for the future data set. How your data going to vary? So like what is the stream flow you can going to vary, and what is going to be the things. Okay. So you can see this figure, some of the figures. So some you can see here. So here, first of all, in the thing here, percentage the, you can say, seasonal historic and stream flow between the, you can say, historic stream flow and observed stream flow. So whatever you are getting from the climate model data set and what is the observed stream flow, you can see some of these things. So this is the percentage error means for each model, what is the, you can say, error which is going to come between the observed and then what is the going, what is getting from the this thing. This is like a historic means that which is already past time period. So suppose last 30 years we are able to make means that is the thing what we are going to simulate here. Okay. So here, so first of all we are doing the percentage error between the historic and these things. So then we can, same thing we can apply for the future. There we can get the percentage change we can get. How much is the in the stream flows. So this is the important output from after all doing all the, you can see, these things. So here you can see here for each model what is the, you can say, change, percentage change between the historic period and future period. You see each model is showing some change. Some they may be the showing the, you can say, positive change, some they are showing the negative change. But when you are applying, you are taking an average. Suppose here the 5 models are there. So on 5 models and an average, what exactly they are representing. So the here you see the most of the things we combine, you will come to know some models they shows that the stream flow is going to reduce. Positive means this is like a change. Some they say that seasonal flow may, you can say, increase. Positive change that may decrease. So here you see always one thing you remember here, out of 5 models you selected, 3 models here, 3 models, 4 models, and then 5 models, 4 models here. Most of these models says decreasing. That is the exactly what we understand, what we require actually. Means you selected 5 climate models, 3 are showing the, case almost 4 are showing the decreasing trend. Means say that when it comes to historic period, future, the stream flow is going to reduce in the basin. This is important observation we need to drive from the study. And similarly, you can say the annual stream flow, how it is going to change from historic and future period. Same thing here also. Annual, you can see historic, you can see the change, stream flow and observed stream flow things. So here some of the things, climate model, some they are showing positive, some they are showing negative. And one thing is on an annual basis, if you take, this is all like a historic thing here. So it is like a, so this is like a comparison between the historic and the, you can see, period. Here future period we can see here. So difference between the historic and future, how the, you can say, annually, how do you see in most of the periods. Suppose next 30 years if we consider from 2047 to 2045, 2064, most of the cases you see there is a decreasing there. In some cases, some years it is going to increase. So this is like an important point for us, which is we are going to see. It means on average 30 years you consider how many years the flow may got less, how many years the flow may got increase. At the same time, how many models they say water is going to reduce and how many models say water is going to increase. So it's like a period which is going to explain how the changes are occurring. Okay, so here, so you see all the models, how they are doing the simulation. This thing you see, observed and historic period. This is the thing, and future. This is going to be the, you can say, period. Means we have to compare with this one. Here, in some cases, they say that future flow is going to, you can say, increase, but we need to, you can say, check with the, you can say, historic what it is says, and then you see in this case, some model says that this is going to reduce. So if it is stream flow is increasing, means what may be the reason? Like the sudden rainfall may occur, and in futures maybe the rainfalls which may really influencing the stream flow. Sometimes there is temperature increase may be there because of climate change. The snow melt runoff may be there. Snow melt also they may cause the things. So that all things we need to look at here, how the, you can say, this stream flow really going to influence. Okay. So on average is the, you can say, trend. So here cumulative annual stream flow, if you see, there are even features also there, future periods also there. So there is like a, when you go on doing for the future, they are going to flatten. Flatten means, yes, we can say that there is a this cumulative flow. The flattening curve means there is like a, the flow whatever you are going to increase, it may be like a not so high. Okay, so even we can get here the, you can say, here from this model, what is the observed stream flow on this minimal precipitation. We can see each basin wise how much is there, and each, you can say, the you can say stream how much water is there. That all things we can able to see in the model visualization. And same thing you see that these figures you can get here. Same thing you can see for the future. So in the future, you can, this is the historic period, and this is the future period. You see the future periods when compared to historic, sometimes, most of the times, you can see there is like a reduction in the, you can say, values. Sometimes there is increase, sometimes the reduction is there. Stream flows in the, you can say, basins. So this study basically tell us for us exactly the, what is the, you can say, here basically your, you can say, conclusions for your study, how the, you can say, rainfall is going to change and how the stream flow is going to change. As you observe, like each season, each year, what is the things are going to change. So we observe that there is really some change will be there. Sometimes the increasing trend for seasonal wise, annual means it may reduce, some seasons it may reduce. You are getting, so you can improve the results further also, like making a multimodal ensemble. We took the individual models were verified. You can go for ensemble approach. You may get in a better way, and you can study in a better way. So this will give a really a input for us to take up any of the later adaptation plans and how we can adapt to this climate change. Okay, similar case study, most of this case study here. So I will tell you the, this, you can say, show you the similar, like most of the initial things. Now I may not explain you, since I explained you how to prepare the database, how to run the model, all the things. Now directly I will, you can explain this case study, just like a database initial things what are there and how the outputs you are getting, so that you can see how the results are there. So we took now this time the case study as the Warangal district itself. It is a combination of so many watersheds. So as a combination, really, how you see the Warangal old district, how the water, you can say, scenario will be there in the future condition. This also we can study here. So here this is the Warangal. Old Warangal is like, you know, some more districts are divided, but this is like a old Warangal which we worked. You see the number of so many. You can see this is the number of tanks are available. So each tank has one drainage system is there. So any change in the climate really influence these tanks. So most of this area, you can say, rain-fed or it is called semi-arid region. The tanks are very important for this region. So that's why the government here also they are picking this tank regeneration. So we can identify the how the climate really change may influence this river these tanks. These are the climate points which are coming here. Just I will go on show you these things slides. So you can really get like what are the points are there. So this is the drainage system. You see, important thing is you see some of the drains are flowing this side, some of the watersheds. See the one more watershed like this. So different direction they flow. This is in submerged study. It is not one basin, a group of basins. So what you will do in this study is you will take one basin where the observed data is there. You do all the, you can say, parameters. You will find out. You apply same parameters to all the other basins. So that this is called actually regionalization. So that we can study the nearby areas also. The different basins, we can divide the whole area into different basins. This is the one basin where the outlet there is a gas station is there. This is the place where you are applied our, you can say, all model. Then you apply to the all climate change impact on the all the basins. You see the calibration, like this is the, you can say, observed on, this is the, you can say that over the years how the, you can say, rainfall is there and what is the rainfall change in the, you can say, rainfall variation and runoff variation is there. Similarly, this is for the future scenarios. You see the future, like maybe we made it 3 future periods, like 2040, 40 to 70, 70 to 2100. That's why the way that we did actually. So this is like give the scenarios. So you may see in this way, you may get in a clear, more clear picture, like how the, you can say, rainfall is going to change for the, this is the existing ones. You see the things, the climate data set, annual rainfall. You see the, this is the observed one. Future up to 2030 there is a trend in the reduction, then is increase, then it may become stand. So what is that clear shows that there is going to be definitely a less rainfall amount and compared to the historic one. So here different future periods we took here actually, like each like a period of like a 10 years. Each feature for 10 periods, how really the stream flow going to the, you can say, change. Okay. So water is availability from the stream flow from each period. You see, is like a different periods which are available in the observed historic time. Future, you see the values goes on reducing. Sometimes maybe more, but most times it is like a reducing. So this tells us like a whether it is available in future or not. So it's definitely going to reduce in the future. So we need to take the, you can say, study okay, some factors like a adaptation strategy. Here the government is, they are making the like a tank regeneration so that 1 year rainfall comes means we can fill those tanks, and they're also filling with the something like a bringing water from Godavari and trying to fill those tanks. There is a climate change impact is there. Okay, so this is the change. So overall you can say the summary. So these studies are, you can say, this particular case shows that there is a overall reduction in the stream flows for a period. Some part, at least last 40 years it will reduce, later it may increase, but the present going to the next mid-century is the period where the things stream flow is reducing. Okay, so these two, most of these things are available in the, you can say, publications, what are presented case studies. So they are like a, these there are, you can say, papers. Most of you can maybe download these things. First 2 case studies are the 2 publications from ourselves, our students, where we published these works. And third also, like we are working completely on like different aspects of this Krishna River and then Vardha River. This is one sub tributary of Godavari. You can get all these data sets here. So some of the references for these works which we studied, these are things. And some of these, like these are all our works, you can say, where I did a postdoc research work initially on the US watershed. Then my student continued this work as a study for this US watershed. Similarly, other MTech student, graduate student worked on the Indian watersheds. And now the BRICS project our students are working. So they are making all the things. What are some of the research shows? They are the inputs, outputs from those studies. So this is we can say my most, you can say, aspects on the climate change impact studies on the different things. So I see like now the data sets available with things. So within a short period of time, we can study clearly in each basin how the climate change really going to influence, going to change, or you can say going to affect the things. So with these inputs or outputs, you can plan the adaptations. That is the second step. So with this, I can take up the questions from the, you can say, participants related to the studies.
Thank you, Dr. Venkata Reddy garu.
Thank you, sir. So thank you for this opportunity, sir.
Then I request all the participants, if you have any questions, queries, or clarification, please text your question. So sir will be happy to answer your questions or clarifications. Sir, మీకు ఆ స్క్రీన్ లో కనిపిస్తుంటాయి questions.
Okay, sir. Okay, yeah. So how many participated, sir?
So there are about 80 ఉన్నారు, sir.
Okay, sir. Okay.
Sir, there is a question from Sridhar Curry.
Okay, are watershed maps available in JS environment? Yes.
Sir, there is another question.
Okay, sir. This India where this is the, you can say, India where is website. So this website it is there in the, you can say, my, you can say, lecture time it is there. So you can get this India where is website one that is there. So you can get a complete data set like now preparing the data by yourself is unnecessary, maybe a lot of errors may be there, corrections may be there. They can use. So answer is there, sir, for them. And what is second question, sir? Second question, sir. Can I see that second question?
Yeah.
How do you assess the accuracy of rain gauge, you can say, data? So how do you assess the rain gauge data? So here, accuracy of the rain gauge data means here.
Sir, Jayaraj sir, మీరు మ్యూట్ చేయండి సార్.
Question to answer.
Sir, please go ahead.
So here, question to answer here. Most of the rain gauge data which are available, so they can be validated, or this is nowadays like we have the IMD data is there, grid 0.25 degree by 0.5 degree. So some of the gauge station data you can take that once and you can compare. You can see the, you can say, you can do the, you can say, regression, or you can make a plot on the x and y axis and you can see how much is fitting. You can see some missing data also, you can able to work on those things. So you can, there is a, you can say, data from IMD, you can say, so you can use for, you can say, corrections. So grid data you can use from IMD data, you can use for corrections. Suppose even you can check your data set with some other nearby rain gauge stations also. Which is available. Suppose you are not getting IMD or some other problems are there, you take the nearby gauge station and you can see whether really it can able to coming in the range or any deviations are there that we can get. So you need to apply the corrections if it is anything is there. You can, for the that also we can do the corrections. Some missing data means there are so many techniques are there. Missing data, you can say how to fill, and correction means how to remove. Suppose if you found there is a lot of deviations, you can remove all the data sets and then you replace with the IMD data and other data sets you can replace. So how we can use the soil data and from where we get the data as it is influence the stream flow is a, yes, is a good question. So here most of soil moisture studies, especially they are very much useful for the, you can say, data sets, especially we are working with the floods or we are with the droughts, those type of things. Soil moisture is very influential. So these also now even most of the, you can see here, microwave data, satellite data sets are available. So they are providing the soil moisture data. They are providing on the, you can say, most of the satellite data. So you can get this. Even you can say bone also you can see the soil moisture data. So they are you can say these all data sets they are available in the bone or different, you can say, satellite systems. So there you can get, and then you can use even USGS. There also they are providing the some of the, you can say, soil moisture things. Some specific satellite microwave satellite data are there. Micro satellite systems. They are all providing the satellite, you can say, soil moisture data sets.
So
satellite data you can use for soil moisture.
Sir, there is another question. Can you suggest methods to bias correction?
I will use, sir, here. So here soil data you can use for soil this thing satellite data is like now almost like they will stream for every day. Every day you can get most of the satellites. So basically this is like a microwave data. So when come to the, you can say, bias correction, as what are the method I showed to you is a very starting method in the bias correction, like where you take the monthly averages and you will divide with the, you can say, one with the observed with the you can say simulated or future data with the present data. But most advanced methods are the quantile mapping. So quantile mapping methods are there, and then there are the other advanced techniques are there, which are like a graphical methods are there. So they are like provide you more versatile, you can say, a way of correcting the bias. So once we go on working with a very localized ones, high-end studies in the climate change, really you need to go for a you can say more, you can say advanced, you can say bias correction studies. So one of the one is you can say quantile mapping and graphical methods. and most of things are there. They are available as a tools in the Python programming and R programming. Simply feed your data and you can get the bias corrected data. Only thing is you need to know how to apply a specific tool. So quantile mapping method is the one of the bias corrected method. This quantile method is the one of the, you can say, widely used methods, and this will correct in a more, you can say, better when compared to the whatever the method I showed to you in the thing. That is very simple method. And you don't need to write by yourself like equations. You can, there are like R programs already available, Python or things, which is just you can say download to your system, apply that particular, you can say, data set, you can get the bias correct data set. So then we can spend like what is the, you can say, the yes, what is the role of evapotranspiration? Yes, evapotranspiration, the climate change, that is like it is like not only the, you can say, one, you can say, role, as I forgot to tell some of the conclusions when I'm explaining our future things. Now people are more, you can say, interested in climate change as the water, food, energy, and access. There, how the water change will influence, how this water change will indirectly influence the food production, means crop yield. So crop yield, water, this evapotranspiration very important. So climate change is there, evapotranspiration will normally, temperature is rising, means evapotranspiration will increase. When there is evapotranspiration more, means the reduction in the stream flows, which is otherwise appearing as a stream flow in that time. That is the, you can say, thing. So this all like we can get from the climate change studies. So they are like very much useful evapotranspiration. Now, only one aspect that we studied like extreme flow analysis, how it is going to change in the future. You can even study the evapotranspiration also in future. They are very much useful for the crop yield studies. Especially you want to study crop yield, how particular rice crop is yield is going to reduce or not. All things you want to make means this, they are very important actually.
The
Evapotranspiration will reduce the, you can say, stream flows. So important in the, yeah, just one more question come, just I will answer it. That previous question, can I see once? I think there's some question. I think I missed that question. It's possible to see the question again. Yeah. What is the tool software that can be used statistically or dynamic downscaling? So the dynamic downscaling. So we have the one, you can say, software that is called WRF, Weather Resource Forecast Model. So for the dynamic downscaling, just I am writing here the method of the model. Weather resource forecast model, the one more that is called precious model. So there, this is like a one, you can say, model where you can apply all your global data you can give. So it will try to, you give the grid size, like where suppose you want to work only suppose some area in the, you can say, one particular basin, small basin of you can say thing. Suppose Nagavali basin you are working, at Navamsadara basin. There only you can able to make the grids, and then accordingly you can run for that particular thing with the boundaries of the global model, and we can get. When come to statistical downscaling, it is like a, some softwares are there, so that is called, the name itself, the statistical downscaling software. Yes, the SDS itself is available. That is like with that name only. So there you can give the all the input data of the global, and you give the your local size, what is the grid size you want, and you need to provide the local parameters there, like what is the rainfall there, temperature there. So accordingly, it will bring the relationship between whatever the, you can say, your variables which you are going to simulate for the future and variables which are already there. So accordingly, you can downscale those parameters. So that is statistical downscaling software, the SDS itself. So here, do evaporation affects both stream flow and infiltration? How could we model that? Yeah, stream flow means most of the, you can say, models where the evapotranspiration is there. You know, there is a Hargreaves equation is there. They're all like a useful for us. When the rainfall is a water balance component, like a water budget. So how much rainfall comes in that, how much part of the things goes as the evapotranspiration and how much remains. In that remaining water, then we can look for it will go as infiltration and some will come as a stream flow. Like I said, like a stream flow. I said not stream flow. Already there is a I'm said like a SWAT model. SWAT model contains the tools which simulate this evapotranspiration for each and every hydrologic response unit, and it will take out the from the rainfall, take out the evapotranspiration, and remaining it will give to the you can say available for infiltration and stream flow. In that part, some part will be go as infiltration, and remaining will come as a stream flow. So I think you know the fundamental basic equations of the you can say water budget, like a total you can say runoff is equal to the you can say total rainfall equal to the runoff plus you can say evapotranspiration, these things. So there each one become a one equation. Accordingly, we can solve those things here. That is the you can say water budget equation. So evapotranspiration normally there is inbuilt models are there. One of the Hargreaves model. They are like estimating the evapotranspiration, which will account for the how much is coming as a evapotranspiration will go. So it will infiltrate. It will influence both the things as the somebody question told. It will influence the both the you can say stream flow and infiltration also. To convert net series to XLS format. So here there is you can say this some question is like how to convert this .ncl files to .xls formats. Here, so here R programming. If you go to the R programming tools, so you can convert into this Excel. You can say tools very simple. Even there are Python tools are there. So here, if you go to the, you can say when we are worked actually, so we made we developed the fundamental, you can say some of the you can say functions in the R programming things. We developed the tools to convert from NC files to the XLS files. Nowadays they are given a very you can see even the interface based ones where you can give the input to our you can say .nc file for a particular area, and Excel file as a each one is one grid. We can get a XLS file which you can input to the model. So only thing is such the things like a R programming. There is a something called NC .nc files to you can say .xls files conversion. Those all tools are available. You can check most of the times those tools you can get. Our case we use some functions which are available, and then we wrote our own you can say programs to convert those things by using the fundamental you can say formulas. Suppose it's a quantile mapping is there. If you give the NC file in the input, quantile mapping will be done, and automatically it will give as Excel sheet as output. Separate tools are available. Question can once again the question can see this question. Question about that previous morphometric analysis. Are the morphometric analysis required or not? What formula you suggest for estimating the ungauged catchments? Yeah. So as said now, like this is also a very important question when come to the I can say gauged and ungauged sets where we are doing a lot of simulations. Definitely morphometric analysis is very important. You are doing the regionalization. Means one area there is a you have the observed data set is there. Other area there is no observed data set, so you can't apply the model there. So in the morphometric analysis, like what is the I can say stream length ratio, what is the type of basin, what is the stream length, stream order, and stream shapes. So they will all like and what is the time of concentration, all so many some 10 to 15 parameters are there. So with those parameters you will compare between the you can say which is already gauged one and ungauged one. Accordingly, you suppose whichever is the ungauged one is matching with this one, you can transfer all the parameters from the hydrological model. So this is like a very important. This morphometric analysis is important for the. So this is important for the you can say ungauged watersheds. So this morphometric analysis is important for the ungauged watersheds. Just I am writing for this thing for data transfer, or you can say regionalization of the Yeah, this one. So morphometric analysis, as this is like a resolution, just like you see small spelling of things, but you can see the major important thing when I'm explaining. Then writing some mistakes, spelling mistakes may come. So it's like conjugate watersheds. Regionalization is important. So then IM data is in grid for extension and a tool to convert into workable format. Can we get the shape files of India, river basins of India and state boundaries? Yes, this is what I am saying. So now data set. So when we start when working these things, everything we have to prepare by ourselves. Now India Varies website is there. So most of the data sets are available online. You can each and every river basin, boundary, everything is available. You can go to the websites and there you can get all the things. So India Varies is the you can say place. So it is there in the, you can say my slides also. So you can get so you can get in the, you can say all in you can say shapefile format. Somebody asked like IMD is available in a grid format. So no problem, it is available in grid format also. You can say convert. There are so many tools are there. So generic tools may be there. So you convert them into each one grid into one XLS format. There you can apply the bias correction. Those things also you can apply. No need to be in the NC format also. It is available in grid format also. We can make. So, but most of the things, whatever we download the IMD grid, they are available in the, I can say, .nc format for this whole India. At almost like 100 years they are providing now. It's a very good thing actually. So that is 70 years, sorry, maybe the mistake. But there, like you can really get that data for the climate change studies. Most of the studies can be done with that data set, especially the observed for using for the calibration, validation for the as historic data. We can use this one. Yeah, I think most of the questions I answered actually. So some other anyway later also they can anytime there they can call Reddy sir, and then if anything is there later also I can tell that the thing. And most of the things are available in the I can see even that's it like a published papers are there. So you go to the you can see even our NIT website. They can most of the things are kept as a push paper, so you can download nowadays. Most of the things are open source. So you can get anytime, any point time you can get means even mail IDs, everything is available on the site, and then even the starting of this presentation given. So anytime you can ask. So we are very much you can say available for you to help in this regard actually. So whatever is there with us, knowledge whatever is there, we are ready to share with you at any point of time.
Okay. If no further questions, I would like to thank profusely Dr. Venkata Reddy garu. I was just observing that it is like a classroom where so many questions asked by the students. See, sir, I would like to, inform you that many of the participants are research scholars and researchers, scientists.
Okay.
You might have observed, sir, that there are specific critical clarifications asking you.
Yeah. So I also felt nice actually. There's some good questions are there. Always the speaker felt nice when we got some good questions. Means they are understanding the things and they are following
Don't
whatever.
feel that they are testing your knowledge, but we are at the lower, so we are trying to learn something from you or know something from you, at least where they can get. Few of the students who are there in that group, my students were asking on that.
Okay. So that's nice. Oh, is it?
Sir, if somebody approaches you, sir, please help them.
Yeah, definitely, sir. That whatever is the
As a
source is
teachers,
available with
we
us.
are here to help the students or the researchers.
Yeah. So this is definitely will help these students at any point of time. No problem.
So, thank you very much, sir, for accepting us our invitation and spending your lot of time preparing PPTs, and now coming online. We are spending our almost 1.5 to 2 hours time with us. I mean, sharing our expertise, field work, knowledge, and computational modeling techniques. And some small questions I was looking how to convert one form of the file to the another form. So the
Okay,
basic
sir.
questions also I thought you answered them. And
Okay,
for
sir.
that, we are greatly honored, sir. And thank you very much. We will be looking forward to associate with you in future also.
Yes, sir.
I have
Definitely, sir. Definitely.
network for this.
Yes, sir. Definitely.
I thought very few people are working in climate change and its scenarios, especially in different in Indian scenarios, and also field also very few people were doing. So I think one of them you are working in this area. Thank you, sir. Thank you very much once
Thank
again.
you, sir. Yeah.
And
Thank you,
this
sir,
program
for
is
giving
sponsored.
a good opportunity for our students also, like you are there for now because of this typical situation. Most of students are away from their, you can say, regular routine things. But because of this type of programs, really once again bring them into the normal mode of working, and they can get their knowledge where they are missing. Now they can get through this type of things. It's really good, you can say, initiative, sir. This is nice thing actually.
Yes. So this program is also supported and collaborated by Science City of Andhra Pradesh, Government of Andhra Pradesh, headed by the chairman of this Science City is Honorable Chief Minister of Andhra Pradesh, and
Hello,
the
sir.
Chief
Okay.
Executive Officer is Dr. Jairam Reddy garu. I think you have,
Hello, sir. Yeah,
sir,
that's nice
say
thing,
hi
sir. Yeah,
to him.
yeah.
Thanks, sir.
Yeah, it's a nice thing actually. So nice to interact with you, all of you.
Thank you, sir. Sir,
Hello.
sir, Venkata, sir, thank you for accepting our invitation.
Yes, sir, sir. Thank you, sir. Thank you for this
Hello,
opportunity.
sir.
It's a real nice thing. Yeah.
Hello.
Hello, sir. Yes, sir. I could listen, sir. Yeah.
Sir, thank you for accepting our invitation.
Yes, sir. Yes, sir. Thank you. Thank you for the
Charan
calling.
garu, you can stop the live. Charan garu, stop the live.
Okay.
Uh,
Oh,
Charan garu, stop the live.